Hello, my amazing students. This is Mrs. A back in the closet again, making a video for you. I am determined to get this done, but we are having the best time here on our vacation. So I hope you're having a good time too with your weekend. Today, we're going to move into what we do when we're looking for the population mean, but we do have a standard deviation of the population known. So we just have a few more things to talk about here. Remember, this is not a very normal situation that you actually have the population standard deviation when you don't have the population mean. But as we're going to see, with very large samples, we have a little bit of a way around this that allows us to use the standard normal table to get our critical values. And so now we're going to investigate those options that allow us to use the standard normal table. Okay, so here is the first slide that is with the sigma, or the standard deviation of the population is known. So we are estimating a population mean. Now on your slide series, this is slide 173. So this is way into your slides, and I think there's 198 slides. So we've got about 25 slides left to go that deal with this situation when the sigma is known. So this is not a very normal situation, but we do need to know what to do when we do qualify to use the z-score instead of the t-score. Okay, so it says if we do somehow have the value of the sigma, the confidence interval is constructed using the standard normal distribution instead of the student t distribution. So the same procedure can be used with this margin of error. So they've changed the margin of error a little bit because we're using z-scores instead of the t-scores. Okay, so you're just going to use a different set of formulas here. And remember, this is the 5th and the 6th of the 6 cheat sheets that I put on here that I constructed for you. Constructing confidence intervals for mu, the mean of the population, when our standard deviation is known. Okay, so it says n is greater than or equal to 30 or sigma known with normally distributed population. So there you have your two opportunities to use z-scores instead of the t-score. Now remember, when we have a population that's large, remember what happens to the t distribution as n gets large. It turns into modeling the normal table, doesn't it? So as you look at your t distribution and your n gets large, go compare that with the standard normal table of the same situation, and you'll see the values are so close together that we could use actually either one of the distributions at that time. So when sigma is known with a normally distributed population, or when sigma is not known but we have a sample size that is big enough for us to use the standard normal table. So here's the cheat sheet that goes with this one. Here is your, remember at the beginning we find our sample statistics such as our n and our x bar, and our x bar, that's an x bar there, it's just not very close there, is the summation of all of your values over the sample size. And then specify your sigma if known. Otherwise, if n is greater than or equal to 30, you can use the sample standard deviation instead of the sigma. Okay, we can estimate the sigma using the sample standard deviation. And we would use this to find the sample standard deviation. So just a little bit different in the formulas. Okay, oops, I went backwards instead of forwards. Let's go forwards. There we go. There's the next slide. Find the critical value using the standard normal table, because we've met the requirements to use the standard normal table. And there is the margin of error formula here. And remember, those are both the same formula. And then we're going to find the left and right endpoints of your confidence interval. Okay, and that's the same procedure we have used before. Okay, so that is your last cheat sheet there. So remember, at the very beginning in 7.1, we were talking about population proportions, and I had two sheets that looked just like this with a big blue line across the top. Then when we got into means of the population, we used the same. We had two sheets that were made up for that with the big blue line across the top. And finally, now with the sigma known, or a sample size greater than 30. So for each one of those, you're going to see two screens like this. This is kind of the cheat sheets that I've made up for you to give you the important formulas for each one of those scenarios. So now we're going to go on with finding the confidence interval. So here's an example. So it says use the 15 birth weights of girls given below, for which N is 15 and X bar is 30.9. Now here our sample size is small. So if we want to use our standard normal table, we had better know our sigma. And in this case, we do. It says construct a 95% confidence interval estimate of the mean birth weight of all the girls, assuming that sigma is known to be 2.9. So here we go. So the next one says check and see if the requirements are met. The sample is a simple random sample. Okay, because the sample size is N is 15, the requirement that the population is normally distributed or the sample size is greater than 30 can be satisfied only if the sample data appears to be from a normally distributed population. Okay, so then we check that, and also we have to know the standard deviation to be able to use the z-score, okay, or the standard normal table. So here they're showing that the requirement, the sample data appear to be from a normally distributed population, and we have the sigma. So we can use what we just saw on the two cheat sheets. We can find the margin of error. We're going to go to our standard normal table. We're going to look up the 95% confidence level, which we already know is 1.96. We're given the sigma, so we put 2.9 in that spot. We have a sample size of 15, so we put the square root of 15 down there. We crank that thing out and we get 1.467. Then we use that, remember that's our E, our margin of error, and then we're going to use our X bar as our point estimate. X bar is our point estimate. We subtract the margin of error, we add the margin of error, and we get our confidence interval right there. So the process seems much faster because you know more about what you're doing now, and you know how to focus in on the things that you need to get. So remember, the example illustrates the situation in which the population standard deviation is known, which is rare. The more realistic situation with the sigma unknown is considered in part 1 of this section. So part 1 of this section was when we used the t-distribution. So remember I said that was going to be the most normal when we use the t-distribution. This is the more rare situation here. Okay, so here it says, how do we know how to choose one or the other? When do we choose the student t, and when do we choose the z normal distribution? Okay, so basically here are our qualifications. Okay, so you can see that when sigma is not known and we have a normally distributed population, we can use the student t. when sigma is not known and our n is greater than 30, we can use our student t. But we have to either have normally distributed or n is greater than 30, even to be able to use the student t. Okay, if sigma is known and normally distributed, or sigma is known and n is greater than 30, then we can use our normal distribution, our z-score. Okay, so notice it says reality, sigma is rarely known, so this is going to be an unusual situation here. Population is not normally distributed and n is less than 30. We cannot use either one. We would use something that is not in the course materials that we're doing right now. It's outside the scope of this class. Don't worry about that situation. Just tell me you cannot find the confidence interval using the methods that you've been taught. It doesn't qualify. It doesn't meet requirements. All right, so here is a really cool flow chart that I have here. So I'm going to go with you through it. It says, how do you know when to use the normal or the t-distribution? Is n greater than 30? Okay, yes, then you may use the normal distribution because you've met the requirement. Okay, and then it says no. If the population is the population normally or approximately normally distributed. So you're going through a flow chart to ask yes or no. It's basically going to end up being the same thing though as this right here. These are the rules, and the flow chart's just taking you through the rules a little bit more slowly here. Okay, but it's kind of cool to watch, isn't it? All right, so here's our little cheat sheet. This is at the end of your PowerPoint. If n is greater than 30, then you meet the requirements to use the normal distribution. Right off the bat, because of our central limit theorem, we can assume that the population, the sample is big enough to model the population. So we can use the normal distribution right off. If the sigma is known, use the s instead. Okay, so if n is less than 30 now, we have to flow down here and make another decision. Is the population normally or approximately normally distributed? Yes. Then if no, we have to say, hey, we can't use either one of the distributions. This is not a problem we can do right now. It's not within the scope of this class. Okay, so then if we say yes, then is the sigma known? If the sigma is known, then we can use the z-score. If the sigma is not known, then we go down here and we use the t-distribution instead. All right, so that's a really good flow chart just to tell you when to use what. And then, we go the right direction here. Let's look at just finding the margin of error, and let's talk about the qualifications here. It says, recall from an earlier slide, a social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of the number of friends for 40 users of the website. Now, the 40 users is the sample size of 40. Okay, so since we have greater than 30, we can use our S, which is our sample standard deviation, instead of our sigma, because we say our sample size is big enough that we can use our central limit theorem and say that our sample data at least approximates our true population. So use this data and a 95% confidence level to find the E. So we're looking for the margin of error. Okay, so we go through here. 95% means that we've got 0.025 in each tail. We've talked about that before. We can use the z-score. And so we go to our z-score table and we get 1.96 because that's what goes with 95%. And then we are able to use, because it's greater than 30, we can use the standard normal distribution because of the central limit theorem. All right, so that allows us to do this. And we plug it into the formula and we get out 16.4. Okay, so we don't know the sigma, but since n is greater than 30, you can use S in place of sigma, which is your sample standard deviation. Okay, so 16.4 is our margin of error. And then we would construct the confidence interval. This was data that I showed you earlier in the slides. Okay, so we'd subtract the margin of error. We'd add the margin of error. And we get our confidence interval. There it is. And here's another one. The college admissions director wishes to estimate the mean age of all students currently enrolled in the college. Okay, so now let's talk about the qualifications, because that's what we really care about. So we have a random sample of only 20 students, so our sample size is too small. Okay, the mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years. So even though we have a small population for our sample, a small sample size, we have our sigma is known. Because our sigma is known and because it is normally distributed, we can go ahead and use our z-score. So we're going to go with a 90% confidence level. Because it's 90%, we already know that we got 1.645. That's on your common confidence level chart there. We plug it into our margin of error formula. We click that out and get our left endpoint and our right endpoint, and we have our confidence interval right there. Okay, so that was 2 examples. One of them was when we had a greater, right here, we were able to use because we had greater than 30. And our, we didn't know our sigma, but we had greater than 30 users, okay? And then over here, we were able to use it. There we go. Even though we had less than 30, here we had a population standard deviation, and our population was normally distributed. Therefore, we were allowed to use the z-score here as well. Came up with the answers. And there's our population confidence interval of the mean. So, interpreting the results. The mean is a fixed number. It is either in the confidence interval or not. It is incorrect to say there's a 90% probability that the actual mean is in the interval. It is correct to say if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain the mu. And there's just a picture of that. Then we go into our sample size, and our sample size equation is a little bit different because we're using our z-score instead of our t-score. Okay, but it's basically the same type of concept here. We calculate the minimum number that we need to be able to do the estimation here, and we plug it in there and get n is 220. Since we're going to round up to the next one, 221, we need at least 221 users in that sample. So here's your homework for 7.1. Here's your homework for 7.2, and we are done with 7.1 and 7.2. So I hope that this helps you, and I am going to go eat supper with my grandchildren. 7.1 and 7.2 are done.